Sir. Today topic is electricity. So we are going to discuss about electricity topic. So electricity is nothing but the rate of flow of charge. So today we are completely discussing about electricity topic. The rate of flow of charge. Welcome to the class. So this is your Subha sir. So today we are going to discuss about electricity topic. Rate of flow of charge. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. So hello, hi everyone. Welcome to the Student Brand. So today we are going to discuss about electricity topic. We are discussing. In this topic, rate of flow of charge. So electricity is nothing but rate of flow of charge. I equal to Q by T. So I equal to Q by T we are discussing. Now we'll discuss about current. Okay. So current is, if you are taking current, equal to Q by T I'm considering. I equal to Q by T. The rate of flow of charge. I equal to Q by T. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. SI unit of charge is coulomb and SI unit of time is second. So completely we'll discuss about electric current. CBSE grade 10 physics. So very important. Make sure that you are attending until the end. So I'll discuss all the points. Okay. So now we can see. Now I'm considering electric current. Electric current. So electric current if you are taking, if you are considering the rate of flow of charge. Hi. What is that? Priya Anjana. So hi. Welcome to the class. Okay, so now I'm considering rate of flow of charge. The rate of flow of charge. Priya, hi. Okay, so here I'm considering I equal to Q by T. So the rate of flow of charge is called current. Rate of flow of charge equal to Q by T. So I is nothing but current. Okay, so now I'm considering here. Okay, what is SI unit of current? Ampere. SI unit of current is ampere. And SI unit of charge is coulomb. SI unit of charge is coulomb. And SI unit of time is second. Okay. So now we are taking, so the rate of flow of charge. The rate of flow of charge is nothing but electric current. So I equal to Q by T. So Q by T you are considering. I equal to coulomb per second. Very good, correct only. Coulomb per second is correct. Okay, so we are talking about so 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per second. So here you can see. So 1 ampere is defined as 1 ampere is defined as. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So I'm considering, see, if you are taking this cross sectional area, this is a cross sectional area. So when the current is passing through it, when the current is passing through this cross sectional area, so electrons will move like this, electrons will be moving like this, electrons are moving like this. So this area of the cross section. Sir, what is drift velocity? Drift velocity is nothing but normally, so normally I will tell one thing. Normally, so electrons are moving inside of the conductor. Electrons are moving inside of the conductor like this. Okay, so best example, I will tell one example. In a running race, so like everyone are running in a running race. So one person will reach the goal, so immediately, so another person he will go. So like if you are taking this the track, so the person is started, everyone started at a time. Everyone has started at a time, but the point is, so the point is only one person will reach to the destination. So they will start here, one person will reach to the destination, remaining they will be running, right? Remaining those persons are running, right? So in this region, so each electron have different velocity, so with a different velocity. Okay, so each electron has different velocity. So one electron 2 meter per second. Suppose one electron is moving 2 meter per second, another electron is moving 3 meter per second, another electron is moving 4 meter per second. See, the average of the average speed of an electron is called drift speed. Or velocity means in a particular direction the electrons are moving. The particular direction the electron moving. So that is the reason we are calling it as a drift speed. Normally in your in your class you can see, so one person they will get 2 marks, one person they will get 4 marks, one person they will get 6 marks. So the average marks we are considering, right? So here also the average speed of an electron is called drift speed. So speed after resistance due to collision. Yeah, that is also same. That is actually, so drift velocity, that is nothing but okay, so thanks, understood. Okay, fine. So thank you so much. Speed after, yes, that is also we can say, that is also, see, after each and every time velocity changes. So velocity will be exchanged. So that time electron will be having different velocity. That time also electrons will be having different velocity. So that also we can take. Okay, so I hope it is very clear. So now we can go to the next one. Now we are quoting. So electric current is nothing but the flow of charge. Electric current is nothing but rate of flow of charge. Electric current is nothing but rate of flow of charge. SI unit of charge is coulomb. SI unit of charge is coulomb, and SI unit of time is second, and SI unit of current is ampere. So 1 ampere is defined as 1 coulomb per second. So 1 coulomb per second. So in the form of definition, if you see, if you consider, so the flow of charge, 1 coulomb of charge flowing through unit cross section area per second. 1 coulomb of charge flowing through unit cross section area per second, because so this is a cross sectional area. Electrons are moving in this region. So this is the area of the cross section. This is the area of the cross section. Electrons are moving in this region. So how many in 1 coulomb of charge flowing through unit cross section area. 1 coulomb of charge flowing through unit cross section area per second. 1 coulomb of charge flowing through unit cross section area per second is called 1 coulomb of charge flowing through unit cross section area is called 1 ampere. So define 1 ampere. So very important. One more question they will give. Define 1 ampere. Define 1 ampere. If they asked, so if they ask, define 1 ampere. So 1 ampere is equal to 1 coulomb of charge flowing through unit cross section area per second. 1 coulomb of charge flowing through unit cross section area per second. That is called 1 ampere. So very important. So based on this one, quantization of charge also there. Quantization of charge. So what is quantization of charge? So normally inside of the conductor, electrons are moving, right? Inside of the conductor, electrons are moving. Here you can see. So I'm taking this are the this the conductor. So electrons will move. So if only one electron will move, so positive charge, negative charge, positive charge, negative charge, positive charge, negative charge. So what are the charge? So first we will discuss charge, then we will go for the quantization of charge. Charge is a property of the matter. Charge is a property of the matter. Hey sir, your teaching is nice. Thank you so much. Okay, so charge is a property of the matter. Charge is a property of the matter which influence the presence of other charges. So charge is a property of the matter which influence the presence of other charge. Charge is a property of the matter which influence the presence of other charge. So I'm taking, so here there are two types of charges are there, positive charge and negative charge. There are two types of charges are there, positive charge and negative charge. So positive will repel. Positive will repel, positive negative will attract, negative will repel, negative will repel. So we can understand by this, positive repel, positive negative attract, negative will repel. So by this one we can understand one thing, so similar charges will repel each other. Dissimilar charges will attract each other. Similar charge will repel each other. Dissimilar charge will attract each other. Similar charge will repel each other. Dissimilar charge will attract each other. So that is the reason. Charge is a property of the matter which influence the presence of other charge. Charge is a property of the matter which influence the presence of other charge. Charge is a property of the matter which influence the presence of other charge. So here you can take positive repel, positive negative attract, negative repel. So by this we can conclude that so two dissimilar charges will attract. Dissimilar charges will attract, similar charges will repel. So that is about charge. And here charge, I already said if the charges are moving inside of the conductor, so there are positive charges are there, negative charges are there. So alone if you take only one electron, one electron is moving, one proton is moving, one electron is moving, one proton is moving, will you able to say current is flowing? Only one electron, only two electrons. If only one electron, two electron flows, will you say current is passing inside of the conductor? No. So we cannot say like that. So there are bunch of electrons, there are bunch of charges will move. Number of charges move, then only we can able to say current is passing. So here charge, whatever the charge is flowing inside of the conductor is integral multiple of. So here you can take integral multiple, and I think number of charges, that is nothing but either positive or negative. Sir, why you are taking plus or minus? What is the reason behind this? Here I said positive charges will be there, negative charges will be there. Positive charges will be there, negative charges will be there. Positive charges are there, negative charges are there. So here I am considering, so positive charges, negative charges, anyway those are moving inside of the conductor, then we can say so current is passing inside of the conductor. So that is the reason we are taking plus or minus. So here this is the quantization of charge, integral multiple, n is the integral multiple. So that is a number of charges are flowing inside of the conductor. One thing, so you have to remember, on one electron how much charge is present? 1.6 into 10 power minus 19 coulomb. Very most important point. Very extraordinary point, marvelous point, mind-blowing point, extremely important point. This point is very important. You have to remember, in the board exam they will ask for 1 mark. See, so in the problems also they won't give this question, they won't give this point. You have to remember at any cost, you have to remember Curious mind, hi. Curious mind, hi. So here, at any point, at any cost, you should remember this point. Yeah, I said hi. Curious mind. What is your name? So, like that. Can I know your name? Good name. Okay. So here, at any cost, you have to remember this point, because this is very, 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 very important. Very important. Sir, why current flows from positive to negative? Yes, I said. Sir, actually, two types of currents are there. Two types of current are there. But generally, we won't say positive to negative. It is a current. It is current. So that is conventional current. Conventional current. Conventional current. Conventional current. Conventional current. Conventional current. Conventional current is nothing but we are taking from positive terminal to negative terminal. But because of the electrons movement, the current will flow. So why you are saying, sir, two types of current, conventional current and electric current. Normally, twilight gamers, hi. And sir, आपकी क्लास क्या पढ़े तो Shambhu, hi. Curious mind, very good. So your name Shambhu. Okay, done. So actually here you see Sahil, hi. So actually, why you are taking two types of current, conventional current, electric current? Before finding electron, proton. So scientists were given that statement: the flow of positive charges, the flow of positive charges, the flow of positive charges, the flow of positive charges is called current. So, but after knowing electron, proton, so generally the current will pass because of electrons movement. Because of electrons movement, current will pass through the conductor because of the electron movement. That is the reason. So we are taking. But generally, current will flow because of electron movement. Of only electron movement. Before scientists were given the statement, so flow of positive charges is taken as current. But after knowing this one, so if you change the entire things, whatever their experiment, whatever their inventions, whatever their so everything it will be again it will, we have to modify all those things. So it's a big risk. So it's very time waste. At the same time, we can't able to come take that all those things. So hi Daniel, and amazing mind, Ash someone. Okay, thank you so much. And SP someone is there. Hi Daniel, welcome to the class. Like that. See, that is the reason. So instead of changing all those experiment, all those inventions, better we change the statement. That is conventional current. So that's why we are taking positive terminal to current is passing from positive terminal to negative terminal. But actually, current will not pass. So because of electron movement only, current will pass. So whatever it is passing from positive terminal to negative terminal, that we are considering as a conventional current. Whatever the electrons movement from negative to negative terminal to positive terminal, that is electric current. So just we change the statement. When will be yeah, definitely. So now class is going on very well. So everyone are listening and asking doubts. So let's so keep it like that. So physics. So physics. Yeah, physics I'm teaching. Overacting. Yeah, maybe. Satyam. See these people. Okay, it's fine. Okay, fine. Let it be. Come to the point. That's why come to the point. So come to the point here. So whatever the current is passing from positive terminal to negative terminal will be considered as a positive terminal to negative terminal is considered as a Coulomb's law. So Coulomb's law will discuss. Why are you doing this one? See, this is the teaching aid. It's my passion, so that's why I'm teaching. So content you see the content. Okay. So if the content is good or not, you check once. So if it is not, let me know. You can ask any doubts in the content. So someone, Kishan. So you can ask, see the explanation, see my teaching. So if you have any doubts, you can ask. Then you can say, so why I'm doing all these things. You can see my channel. So those who are asking why I'm doing this one, you can see the channel. How I'm teaching, how I'm going to that. So you can observe my hard work, my intention towards teaching physics. So I want to teach in a best possible way. That is the reason I am teaching in this manner. So you can check my YouTube channel. You can, so when you are entering into the class, you can check my display picture, how it is, how it is. So by that you can understand, you can check. There are many experiments, there are many experiments I did. So this is one of my form. Okay. So thank you so much for asking. So we'll go with the concept. Here I'm taking, so charge is nothing but plus or minus any, that is nothing integral multiple. So if you are taking 1 electron equal 1.6 into, I hope someone asked this question. Is it clear? Is it clear? Someone asked this question. Is it clear? I hope it is clear to you all. Okay. So that's enough. Come to the point. Come to the point. So 1 electron and 1 electron 1.6 into 10 power minus 19 coulomb. You are a unique teacher. Thank you. Thank you, Shambhu. I remember your name. So here consider 1 electron equal to 1.6 into 10 power minus 19 coulomb. That is electron. I am considering here. So this point is very, very important. You must remember this point. You must remember this point. You must, if you like this video, please do like, share and subscribe my channel. Okay. So if you like this content, this is ever sir. My channel name is Student the Brand. So if you like this content and explanation, so please do like, share and subscribe to Student the Brand. Thank you. Thank you for joining and listening my class, everyone. So 1 ampere equal to 1 coulomb per second. 1 ampere equal to 1 coulomb per second. So 1 electron 1.6 into 10 power minus 19 coulomb is there. And based on this one more question also they will ask. One more question also they will ask. Actually, so Hindi mein thoda aata. Thoda Hindi aata. So someone who is typing in Hindi, please type in English. It's my request. I am requesting you. So please type in English, so then I can understand. I can respond to your message and what exactly you are asking. So I can respond to your your question exactly, or to your question I can respond. Please type in English. It's my request to you all. Okay. So I'm considering here. So 1 electron, 1.6 into 10 power minus 19 coulomb, and 1 electron 1.6 into 10 power minus 19 coulomb is there. In 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? That is very, very important. So I will tell you how to do it. So 1 coulomb, if you are taking 1 by 1.6 into 10 power, so here 1 by, so I'm considering 1 by 1.6 into 10 power minus 19. So this is electron, right? This is the electron. Now you can see that I'm taking 1 by 1.6 into 10 power 19. So 1 by 1.6 into 10 power 19. 10 power 19. So 27 people are watching. Yeah, thank you so much. So happy to see you all. So here you can see 1 by 1.6, if you are taking 1.6 into 10 by 10 I am taking, so that is nothing but 10 power 19. So you can multiply 10 by 16, 10 by 16, that is nothing but 10 power 19. So if you try to do it, you'll get 0.625 into 10 power 19. So then if you solve it, 6.25 into 10 power 18. Very, 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 very important. Very, 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 very important. Very, 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 very important. Explanation is very, very important. So make sure that you are learning this explanation. So this explanation derivation is very, very important. Make sure that you are learning this one. You are learning this one. Very, very important. Very, very important. Because so this derivation, how you are getting on 1 electron, how much charge is present. So in 1 electron, 1.6 into 10 power minus 19 coulomb is there. In 1 coulomb, 6.25 into 10 power 18 electrons are there. So in 1 coulomb, 6.25 into 10 power 18 electrons are there. So very, very important point, this one. So this they will ask for minimum 2 marks question they will ask, 2 marks question they will ask, this one 1 mark question they will ask, and this one, so 1 mark question they will ask. There is a chance to ask. So definitely this question may ask. So this is for 1 mark, and also this is for 1 mark, 1 mark. Okay, this explanation they will ask for 2 marks. Very, very, very important. Very, very important. Make sure that you are learning this one. Make sure that you are learning this one. Very, very important. I am saying to you all, so very, very important. Practice, practice. You must practice this one. You must practice this one. You must practice this one. Very, 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 very important. So in 1 coulomb of charge, how many electrons present? In 1 coulomb of charge, how many electrons are present? In 1 coulomb of charge, how many electrons present? 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons. See, in 1 coulomb, say on 1 electron, on one electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb. Very, 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 very highly important. So while doing problems, this question will come. So surely, see, they won't give this value. I am telling to you all, this point they won't give in exam. This point they won't give in exam. Surely I am telling. So they generally, we have to remember this value, and this value also you have to remember, because if you remember this value in exam directly MCQ's point of view also they will give. MCQ's point of view also they will give. This question they will give. This also they will give. So try to practice all these point. Try to practice all these point. So now I am going to the next one. So here now I discussed about the quantization of charge and SI unit of current and definition of SI unit of current. Now we are going to the next one. Electrical appliances. So why you are taking electrical appliances? So we are oh my god, where I am even living. So like that we are considering, very, very important, I said. So electric current is nothing but electric current. So the rate of flow of charge, I equal to Q by T, that is nothing but electric current. And electric circuit. Next one, electric circuit, a continuous and closed path of an electric current. A continuous and closed path of an electric current is called. A continuous and closed path of an electric current is called. A continuous and closed path of an electric current is called electric circuit. A continuous and closed path of a continuous and closed path of an electric current. Is called electric circuit. Very, 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 very important. 1 mark question. This point, 1 mark. For 1 mark, this question will come. For 1 mark, this question will come. Right? So electric circuit. Continuous and closed path of an electric current. Electric current is nothing but electric circuit. And next one I already explained conventional current and electric current. So before going to all those points, we'll go to the next one. That is, so cell. So this is a positive terminal, negative terminal. So first one is the cell. Second one is the battery. And third one is, if you are taking, so battery. Third one is switch. This is open switch. And fourth one is closed switch. So I'm taking closed switch, open switch and closed switch, and closed switch. And next one we are going to the fifth one, bulb. So I'm taking the bulb. So this is the bulb. And sixth one, resistor. I'm taking this is the resistor. Seventh one, rheostat. So here I am considering the cell, battery, open switch. If dot is there, that is closed switch. If dot is not there, that is open switch. open switch and close switch. This is the bulb and this is the resistor and rheostat. So the rheostat, the device which is regulate the current without changing the voltage source. The device which is regulate the current, the device which is regulating the current without changing the voltage source, that is called rheostat. The device which is regulating the current without changing the voltage source, is called rheostat. Resistor, these are DC sources, yet first symbol AC source is circle and with inside even yes, very good, Sam, thank you so much. So here you can see, here you can observe one thing. So resistor is a device which opposes the electric current in the circuit. Resistor is a device which is opposing the electric current in the circuit. Resistor is a device which is opposing the electric current in the circuit. Resistor is a device which is opposing the electric current in the circuit. Resistor is a device which is opposing the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Here I will discuss about resistance. So I will talk about resistor. Now I will talk about resistor. So I am taking resistor. Resistor is a device which is opposing the electric current, which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistor is a device, resistance is the phenomena. SI unit of resistance is ohm. SI unit of resistance is ohm. And fourth one you are considering symbol of ohm. So symbol of, this is a symbol of ohm. So once again, ohm. So symbol of ohm. This is the ohm, SI unit of resistance. Once again, you can see here, observe here. So resistor is a device which is opposing the electric current, which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. So this is the symbol of the resistor. Very, very important. Even in the exam, they will ask for 1 mark. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current in the circuit. Resistance is the phenomena of opposing the electric current in the circuit. Resistance is the phenomena of opposing the electric current in the circuit. Resistance is the phenomena of opposing the electric current in the circuit. SI unit of resistance is ohm. SI unit of resistance is ohm. Symbol of ohm, symbol of SI unit ohm, that is this one. This is the symbol. So among these 4 points, definitely I am saying 1 point will come in the exam. So among these 4 points, one question will come for board exam. Very, 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 very important. Expected question from this point. Resistor is the device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. SI unit of resistance is ohm. Symbol you are taking. So ohm symbol, SI unit of resistance. Now we are going to the next one. Ammeter. So I am taking the ammeter. I am considering here. I am taking here. This is the ammeter symbol. So SI unit. So you are taking the current. Okay. So first one is current. Second one is ammeter, and third one is ampere. And fourth one is A. So here you can see fifth one is series combination. So what are these points? So definitely I am telling. So these points are helpful for exam. These points are helpful for helpful for solving the problem, or MCQs also these points can be expected for 1 mark. For MCQs also these points can be expected. So I'm saying, so this is a ammeter. Ammeter is a device. Ammeter is a device which is used to measure the current. Ammeter is a device which is used to measure the electric current. So current is a physical quantity which can be measurable. Current is a physical quantity which can be measurable. So ammeter is measuring device. Ampere, SI unit of current, SI unit of current, SI unit of current, SI unit of current, and symbol of ampere. This is a symbol. See, while you are writing your units, you must use small letter. You should not use capital letter. You should not use capital letter. You should not use capital letter. You have to use small letter, because on honoring the scientist, Mohan, hi. So Mohan, hi. So here you see for ampere we are taking the small letter. We should not use capital letter, because on honoring the scientist, we are using, so SI unit of current will be taken ampere. You have to write small letters. You have to write small letter. If it is starting sentence, if you are writing, so in the starting of the page, you can mention 1 ampere. 1 O is capital letter and ampere. So you have to write in this format. If you are writing from starting page, so if you are using, so you can take like that. But ampere must be written in the format of small letters. All must be in small letters, especially starting letter. You have to write small letter. It's of you, sir. Thank you. And Vaidik, hi. Vaidik, hi. Two doubts, what happened? Yes. Right? Yes, so very important. SI unit of current is ampere. SI unit of current is ampere. SI unit of current is ampere. Very important. Most important. See, why I am stressing this point means, so students, they will do silly mistake. They will lose 1 mark. Many times I'm saying also, simple, Pahal, hi. So here simple mistake. So instead of small letter, they will write like this. This is absolutely wrong. So we must use only small letter. This is wrong. So don't follow this method. Only follow ampere must be written. So in the format of all small letters you have to write. All small letters only you should write. You should not take capital letters, or according to the English format, according to the English. Okay. So rules and regulations, whatever the word we are starting, that must be written in the capital letter. So we are not following our English rules. We are following physics rules. In physics rules, according to the physics. So according to the physics, you must write. So you must write ampere, ohm, coulomb. So all must be written in the format of small letters. Starting letter must be written small letter. That is nothing but ampere. So SI unit of current is ampere. But symbol you can represent capital letter. So for a symbol, yes, I will take. I'm taking classes. Okay, so 6 o'clock you can join. So 6 o'clock, those who want classes, you can see 9849812804. This is my number. You can contact to this number for regarding any concerns regarding any classes. Just go through it. This is my number, 9849812804. WhatsApp is there. You can check once. Okay, so that is about ampere. SI unit of current is ampere. You have to write small letters. You should not use capital letter starting. Starting letter you should not use capital. Very important. So that is nothing but current. Next one we are going to the potential difference. Very highly important, extremely important, mind blowing important, marvelous important, masterpiece class. Every word is a diamond. Every word is a diamond in this concept. Every word is a diamond from this concept. Every word is a diamond from this concept. Very, very important. Very, very important. Very, very important. Very, very important. Potential difference. Potential difference. Potential difference. Potential difference. Potential difference. I am taking. Potential difference. Potential difference. Potential difference. Potential difference, very, very important. Potential difference is very, very important. Make sure that you are practicing this point. Make sure that you are practicing this point. Very, very important. Very, very important. So I'm saying here, very important. So very, very important. You can check. Very, very important. You can check here. Very, very important. You can check here. Okay, so that is nothing but now potential difference. So voltmeter we are taking voltmeter. Voltmeter is a device. So potential difference, potential difference, potential difference, potential difference. Voltmeter measures the 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 potential difference. What is the potential difference and electrical potential? Is it same or any difference is there? Is it same or any difference is there? Is it same or any difference is there? Yes, difference is there. Potential different, electrical potential. So potential difference is nothing but potential difference. First one you are taking potential difference within the conductor. Within the conductor. Within the conductor. So within the conductor. Within the conductor. So within the conductor. Within the conductor, so I am considering here, so point A to point B, point A to point B, point A to point B, so point A to point B, point A to point B. So we are doing some work to bring unit positive charge. So this is a positive charge. We are doing some work. We are doing some work. We are doing some work to bring unit positive charge from one point to another point. Use unit positive charge from one point to another point. So we are doing some work. We are doing some work to bring unit positive charge from one point to another point. From one point to another point. That is called a potential difference. That is called a potential difference. So we are doing some work to bring unit positive charge from one point to another point. That is called potential difference. Potential difference. Potential difference. Potential difference. Potential difference. So W V equal to W by Q. V equal to W by Q. So V equal to W by Q. So V equal to W by Q. What is W? Work. So V equal to W by Q. Work done to bring unit positive charge. Shiny. High. So work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point. From one point to another point. Work done to bring unit positive charge. So Daniel, thank you so much. I understood your your concern. So towards the class, I am very happy for it. Okay, so just we are working on it. So people those are attending or listening, I am very happy for them, and let them listen the class so they can only understand, so they will only understand, so we will see. Okay, so we are doing our work, let work continue, so people will surely they will understand. Why you waste your hard work, less no students will see and make money from this, so take a job and work. Yes, thank you for your suggestion. I'm very happy. So here you are doing work done to bring unit positive charge from one point to another point. So work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So 1 volt equal to 1 joule by 1 coulomb. 1 volt equal to 1 joule by 1 coulomb. 1 volt equal to 1 joule by 1 coulomb. 1 volt equal to 1 joule by 1 coulomb. So 1 volt equal to 1 joule by 1 coulomb. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. So 1 volt is defined as SI unit of potential difference is volt, SI unit of work is joule, SI unit of charge is coulomb. SI unit of, once again I am telling, SI unit of volt is SI unit of potential difference is volt, SI unit of work is joule, SI unit of charge is coulomb. So here I am considering 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. Within the conductor is called potential difference. Electrical potential. So electrical potential is nothing but, so work done to bring, so I am taking from infinity. So we are bringing the charge. So here I am taking this is the field, this is the field. Okay, so this is the infinity point. We are bringing charge, we are doing some work, to bring unit positive charge from infinity to the required field. Once again, we are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. Once again, so potential difference I'll discuss once again, listen carefully. So work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point. So those who are new to the channel, please do like, share and subscribe to Student the Brand. So if you need any classes regarding the physics, you can contact to this number 9849812804. This is the number. Okay, so I had 10 years experience myself. Okay, done. Come to the point. Thank you so much for your blessings. Definitely I will. Okay, so I am potential difference is nothing but work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Those who are watching the class, please do like, so definitely it will be referred to the remaining students also. They will also come and join and learn to the class. Okay, so please do like the channel. If you are new to the channel, do like, share and subscribe to Student the Brand. So this is your Siva sir and channel name is Student the Brand. So spread one word regarding the channel. Attend to the class daily 9 p.m. you have live class daily 9 p.m. and 6 p.m. 9 p.m. you have daily class. Oh Tanishka, hi. Welcome to the class. Okay, so potential difference is nothing but work done to bring unit positive charge from one point to another point. From one point to another point is called so daily 9 p.m. you have live class. So if you subscribe the channel, then sir, are you teaching about electromagnetic wave? No, I'm teaching electricity. Electricity will be helpful for grade 10. At the same time, grade 12 students also. Electricity I'm teaching. It will be helpful for grade 10 and grade 12 students also. So I'm requesting all students, so try to click on like button, that will spread to the remaining students also. They will also join to the class. Every day at 9 p.m. we have live class. You can join to the class. If you subscribe and click on bell icon, you'll get notifications regarding the live class. So please do like, share and subscribe to Student the Brand. So definitely you will every day you'll get updates regarding the physics. So thank you so much. So we'll continue the next topic. Potential difference is nothing but work done to bring unit positive charge. From one point to another point. Work done to bring unit positive charge from one point to another point. work done to bring unit charge from one point to another point within the conductor. If you are doing work within the conductor, that is called potential difference. We are doing some work to bring unit positive charge from infinity to the required field, 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 from infinity to the required field. That is called electrical potential. So here few more points I'll discuss, very important points I'll discuss. I had a great 10 years experience in teaching, that to CBSE grade 10 physics. So you can attend to the class, you can learn the class. Every day at 9 p.m. you will be having live class. So come and join to the class, learn with me. So this is our Siva sir from Student the Brand channel. Okay. So now I am considering the potential difference. So potential difference I will tell. Related to potential difference, I will explain few points, very important highlight points. Definitely it will come for exam. That type of questions I'm teaching. Questions I'm teaching. Definitely you can check once. So first one voltmeter. Second one volt. Third one. So what is that one? 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. That is related to potential difference explanation. V equal to W by Q. So 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. Okay. So here potential difference. So SI unit of potential difference is volt. Sir, I have doubt. What is? So number of electrical lines passing through unit cross sectional area. Okay, na? Okay, done. Come to the point. So potential difference. I am taking SI unit of potential difference is volt. SI unit of potential difference is are dress super. Thank you so much. Please do like and share and subscribe to Student the Brand. Please click on like button, that will reach to the remaining students also. They will also join and learn class. So try to click on like button and subscribe my channel. You will get notification updates regarding physics class and live class. Every day at 9 p.m. you have live class. Come and join to the class and learn. Every day at 9 p.m. and 11 a.m., 9 p.m. and 6 p.m. So these are the 3 classes. Once again, every day morning 11 a.m. live class. First one. Second one 6 p.m. And the third one 9 p.m. So 9 p.m. these are the live classes timings. So live class timings, come and join to the class. Live class timings every day 11 a.m., 6 p.m., 9 p.m. 3 classes I'm taking. So try to join to the class. Is that 11 physics? Yes. So 6 p.m. time. So I'm taking grade 11 for grade 11 and JE NEET, grade 11 JE NEET and MSET students. 11 p.m. I'm taking for grade 10, grade 12, IIT, JE, NEET students and MSET students also. These concepts are helpful. And 9 p.m. also same for grade 10 and grade 12. Grade 10, grade 12 at the same time. IIT and JE, NEET students also and MSET students also can join to the class. Okay, so 6 p.m. definitely grade 11 students I'm teaching. I have doubt in this physics. Sir, why are you wearing this type of dress? Actually, this is my teaching aid, one of the teaching aid. Okay, so I thought this in 12th lecture. Okay, so well, fine. Okay, done. Come to the point. Potential difference is nothing but so SI unit of potential difference is volt. Voltmeter is a device which is used to measure the potential difference. Symbol I am taking, this is a voltmeter symbol. In potential difference also 2 types, potential difference and electrical potential. Formula is same, V equal to W by Q. So formula is same. Okay, now V equal to W by Q. Either electrical potential or potential difference. So formula is same. That is about potential difference. Now I am going to the one more concept. That is Ohm's law. Ohm's law. Very. Come on. So Ohm's law introduction should not be like this. Ohm's law. Come on. So Ohm's law. Oh! So now I am discussing Ohm's law. Come on, join to the class. Ohm's law. So what is Ohm's law? We are now discussing about Ohm's law. Ohm's law. So the potential difference, very important. So we should not tell in this way. So very important. Ohm's law. So now we are considering. So the potential difference across the metallic conductor. The potential difference across the metallic conductor is directly proportional to current flowing through it. The potential difference across the metallic conductor is directly proportional to current flowing through it. So I am taking the current positive direction. Now I am taking here. So positive negative current is passing in this direction, positive negative. So here I am taking the voltmeter, positive negative. So this is the resistor X and Y. This is the key. Current is passing in this manner. Yes. So the potential difference across a metallic conductor, the potential difference across a given metallic conductor is directly proportional to current flowing through it. Statement at a constant temperature. Once again, the potential difference across a given metallic conductor is directly proportional to current flowing through it at a constant temperature. So V is directly proportional to I. V is directly proportional to I. The potential difference. So very important. Once again. Come on. Everyone be active. Ready? Come on. So potential difference. Potential difference across a metallic conductor. The potential difference across the ends of the metallic conductor is directly proportional to current flowing through it at a constant temperature. The potential difference across a given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. V is directly proportional to I. V equal to IR. V is directly proportional to I. V equal to IR. So very important. Very important. I already said. So this statement will give for exam. So this statement again I'm saying very important. Make sure that you are learning this statement. I am giving the triangle format. So here I am considering V, considering IR, V, IR. So V, if you are taking IR, multiply. I you are taking V by R. R you are taking V by I. So V equal to IR, I equal to V by R equal to V by I. So very important. Highly most important. Okay, so make sure that you are learning this point. If you like this explanation, do like, share and subscribe to Student the Brand. Click on like button. Remaining students also, they will come and join to the class. They will learn the physics subject from this class. Okay, so the potential difference across a given metallic conductor. Once again, one more time. Very important. Keep in mind one thing. Keep in mind one thing, the potential difference across a given metallic conductor, the potential difference across a given metallic conductor is directly proportional to current flowing through it, is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. So now you are considering I equal to V by R equal to V by, so I equal to, so I equal to V by R, sorry, V by R, this is I equal to V by R equal to V by I. So very important. So V equal to I equal to V by R equal to V by I. So very important. Make sure that you learn this one. You learn this one. Very. Everybody listen carefully. Everybody listen carefully. I am saying this is Siva sir from Student D brand. This is Siva sir from Student D brand. This is Siva sir from Student the brand. I am telling you, listen carefully. This statement is very important. This formula is very important. This diagram is very important. This diagram alone they will give for 2 marks. 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 Now again come to the point. So now I am explaining the process. Now I am explaining what are the materials required. Now we will discuss about materials required. Materials. What are the materials? First one, 4 cells. 4 cells. How much? 1.5 volts each here. 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts. How many? 4 volts. 4 cells, 1.5 volts each. 4 cells, 1.5 volts each. So 4 cells, 1.5 volts each. I am taking. Second one, nichrome wire. Come on, nichrome wire. So nichrome wire is acting as a resistor is here. Nichrome wire is acting as a resistor. Once again, very important. I will tell. Nichrome wire is an LIF. Nichrome wire is an LIF. Nichrome wire is an LIF. Nickel, chromium, manganese and iron metals. Nichrome wire is an LIF. Nichrome wire is an LIF. Nickel, chromium, manganese and iron metals. This is Ohm's law. This is Siva sir from Student D brand. So now you can see here. This is about nichrome wire. I'm coming to the third one. Ammeter, and fourth one voltmeter, and fifth one switch. I am taking switch, and sixth one connecting wires. Sixth one connecting wires. So now you can observe once again. So once again, what are the materials required? 4 cells. Here I am taking 4 cells. 1, 2, 3, 4. Okay, now 1, 2, 3, 4. 4 cells. 4 cells, 1.5 volts each. 1.5 volts each. 4 cells, 1.5 volts each. Nichrome wire. This is the nichrome wire. So this is acting as a resistor. This is the nichrome wire. Okay. This is the nichrome wire. It acting as a resistor. So ammeter, voltmeter, key and connecting wires. Ammeter, voltmeter and key connecting wires. I hope it is very clear. These are the 4 materials required. Next one, procedure. So what is the procedure? Procedure you can see. Procedure I am considering. Procedure. So take one cell first. You have to connect one cell. Connect one cell first. Connect one cell you have to connect. That is the reason I am drawing the dotted lines. Connect one cell. First you have to connect one cell and take the note down the reading of ammeter and voltmeter. First you have to connect one cell and note down the reading of ammeter and voltmeter, and you have to mention in the tabular form given below. Now I'm giving the tabular form. 1, 2, 3, 4. So 4 you have to take. I'm considering here serial number of cells, ammeter, voltmeter reading. So serial number. So you can say number of cells, ammeter reading, voltmeter reading, V by I. So Ohm's law gives the definition of resistance. Ohm's law gives the, sir, don't shout on. Okay. So Ohm's law gives the definition of Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. Okay, so I'm taking V equal to IR. V equal to IR. So R equal to V by I. R equal to V by I. Okay. I'll resume my class once again. So we can see V equal to IR, R equal to V by A. See, like it's like a vibration. It's like a vibration. Normally, if you see, so if generally voice, if I teach what happens, you'll get sleep. You'll get sleep. I'm not see that vibration. That vibration, if it gives goosebumps. So automatically we can listen carefully, we can be alert, and where we are stressing, where we are pronouncing, so little high pitch and low pitch. So that's the reason. Okay, so don't mind for it. So definitely I will take it positive. Mallikarjuna, hi. Okay, so okay, I will take it. Thank you so much. So V equal to IR, R equal to V by A. So Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. Definition of resistance. So now I am taking one cell connector. Connect one cell. We are drawing the dotted lines. Sir, why you are drawing dotted lines? Why can't you draw normal lines? I am telling you here. Let's hi. Anvesh, hi. Okay, so I am considering here only one thing. So why you are taking the dotted lines? Why you are taking the lines? Why can't you go for another line? Because here I am taking one by one. So first one cell you have to connect, then another two cells, next three cells, next four cells. So like that. So what is your name? Let's do. Hello. What is your name? Can you tell your name? According to that, I will call on your name. Okay, so here I am considering one cell you connect, take the reading of ammeter and voltmeter. Then two cells you can connect, take the reading of ammeter and voltmeter, and repeat the process. Repeat the process for 3 and 4 cells. Repeat the process for 3 and 4 cells. Repeat the process for. Hi Sumit. Repeat the process for 3 and 4 cells. Here I am taking one cell we are connecting first. And note so mentioning the and taking the and observing and writing down the readings of ammeter and voltmeter. So one cell first you have to connect and note down the reading of ammeter and voltmeter. Next two cells, take the note down the reading of ammeter and voltmeter. And so repeat the process for 3 and 4 and mention in the tabular form given below. Mention in the tabular form given below. Mention in the tabular form given below. So this is the process. Very, 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 very important. This is the process. Once again, Ohm's law, the potential difference across the ends of the given metallic wire is directly proportional to current flowing through it. Whatever the current is flowing through the resistor, that is directly proportional to potential difference. So it's here the potential difference according to the textbook you follow, according to the textbook definition you take it, according to the definition of textbook. So the potential difference across the resistor, across the given metallic conductor, the potential difference across the given metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. So if you say normally it won't be good. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. So what is Ohm's law? the potential difference across the ends of the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it. Is directly proportional to current flowing through it. Current flowing through it. Okay, so here I'm considering now, current is flying, current is passing through it. So the potential difference we are taking, that is directly proportional to current flow. So V equal to I R equal to V by R is a resistance. So Ohm's law gives the definition of resistance. So keep this one point in mind. Ohm's law gives the definition of resistance. And materials, what are the materials required? 4 cells of 1.5 volts each. 4 cells 1.5 volts of each. And the next one, nichrome wire. Nichrome wire is an alloy. So you can see in the textbook, CBSE grade 10 physics textbook, you can observe nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Very, very important. We should not say in this manner. Once again, remember this point. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Okay, so that's enough. That is about nichrome wire. So among those 4 cells, we are taking nichrome wire, ammeter, voltmeter, switch, ammeter. So this is ammeter, voltmeter, switch and connecting wires. This is about connecting wires. So this is about Ohm's law. Procedure, next going to the procedure. One cell you connect, take the reading of ammeter and voltmeter. Next connect to 2 cells, note down the reading of ammeter and voltmeter and mention in the tabular form given below. How many times we are taking? 4 times. How many times we are taking? 4 times. Each and every time when you are doing, so we'll get R equal to V by I. So this is constant. This is constant. V by I value is constant. V by I value is constant. Okay. So V by I value is constant. Very, very important. So when you are drawing, just you no need to fill this table. Just you have to keep it like that. You no need to fill the table. Just you can leave like that only. So very, very important. Make sure that you are learning all these points once again. So statement, materials required, procedure, table. So ohmic. So if you draw this graph for VI, if you draw the graph for V and I, that is linear. If you draw the graph for V and I is linear. So ohmic conductors, the graph for ohmic conductors, so V I on x-axis, V on y-axis. So if you draw the graph for ohmic conductors, so ohmic conductors. So ohmic conductors graph, non-ohmic conductors, 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 non-ohmic conductors. So ohmic conductors, what is the what are the ohmic conductor? The substance. Once again, very, very important. One more question. So very, very important. Listen carefully. Ohmic conductor, the substances which obey Ohm's law. Once again, the substances which obey Ohm's law, those are called ohmic conductors. The substances which does not obey Ohm's law. The substances which does not obey Ohm's law, those are called non-ohmic conductors, 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 non-ohmic conductors. So the substances which obey Ohm's law, those are called ohmic conductor. The substances which does not obey Ohm's law, those are called non-ohmic conductors. Very, 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 very important. Very important. Okay, so that is enough. So now we are going to the next one. Now we are going to the next one. Now we are going to the next one. Next one. Next one. Next one. So see, with this everyone, I will sing one song. Actually, I wrote songs also. I wrote songs also related to subject. I'll sing for you. Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see, far distance we can't see. Myopia, myopia, myopia. For that correction we are using. Bro, what bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. So that's enough. So that is about myopia song. This is whatever I'm singing song. That is a concept. So myopia, the person has myopia can see near distance. Myopia, 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 myopia. Near distance we can see. Near distance we can see. Far distance we can see. Far distance we can see. Myopia, myopia, myopia. For the correction we are using. Bro, what bro? For the correction we are using concave lens, concave lens, concave lens, concave lens. So like that. So there are many songs I created. That is the reason I am teaching physics in this manner. So I will one more song also it is there. Very, very important song. So that is about related to sign conventions, light reflection and refraction. 3 more play karo. Thank you. So okay, done. So one more song I'll sing. New Cartesian sign convention, new Cartesian sign convention, all distance measured from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. Like that. Actually, so generally one voice also I'll sing. So without any instrument also. Even guitar also, with guitar also I sang the song. It is there in my YouTube channel. You can see. Without guitar, with the guitar and with the drum also. So in 2 ways I sang. So So you can see. So I'll sing one song and we'll go to the next topic, that is about resistance, related to resistance and resistivity. So last one more time, I will sing one song. So like with normal voice only. Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see her. Far distance we can't see her. Myopia, myopia, myopia. For the correction we are using. Bro, what bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. So like that, I sang the song related to myopia, very very important concept. So difference between myopia and hypermetropia, they are getting confusion. That's why I sang. And one more song, so related to hypermetropia, I'll sing. And new Cartesian sign convention, I'll sing. Okay, these two. Then I will go to the concept. Once again, new Cartesian sign convention. New Cartesian sign convention. New Cartesian sign convention. All the distance measured from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. Actually, this question comes for 3 marks. Very very important concept. New Cartesian sign conventions, 3 marks question will come. See, if you sing in this format, so you can listen the song, there is a depth meaning. As it is lines, you can write in exam also. Like that, I framed the lines also, I framed the sentence also, I framed the lyrics also. Okay, so those all lines, if you write also, easily you'll get. New Cartesian sign convention. So sign convention, another name is New Cartesian sign convention. All distances are measured from the pole. In the direction of incident is positive, opposite incident is negative, above the principal axis positive, below the principal axis negative. That's enough, simple. So I converted in the form of song. So hypermetropia, that is myopia already sung. Hypermetropia I'll sing, I'll go to the next one. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, 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 hypermetropia. So thank you so much. So that is a song. Okay, I hope it is very clear to you all. So I hope it is very clear to you. So if you have any doubts, you can ask me. If you have any doubts, you can ask me. So then we'll go to the next one. So these are the songs. These are the songs till now I created. There are many songs are there. So there are many songs, nearly 10 songs. Nearly 10 songs I created. Nearly 10 songs I created. So if you like this content, do like, share and subscribe to Student the Brand and spread a word regarding Student the Brand channel. And so you can join Student the Brand classes. So every day at 11 a.m. 6 p.m. and 9 p.m. So we'll be having live classes. Come and join to the live class and you can learn physics. And resistance, resistivity. So I'll discuss the topic. So you can see resistance and resistivity. Resistance and resistivity. Resistance and resistivity. I'll discuss. Resistance, the phenomena of opposing the electric current. The phenomena of opposing the electric current. So R is directly proportional to L. R is inversely proportional to area. R is directly proportional to R is directly proportional to L by A. R is directly proportional to L by A. Once again, so resistance is directly proportional to length of the conductor. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Factors on which resistance depends. Factors on which resistance of the conductor depends. Resistance. Factors on which resistance depends. Resistance of the conductor depends. Okay. So you can go for a factors on which resistance of the conductor depends. So resistance is directly proportional to length. So resistance is inversely proportional to area. Resistance is directly proportional to L by A. So rho equal to L by A. So here you can consider R is resistance. R is resistance and rho is resistivity. So I am taking resistivity. Okay. So R is a resistance, rho is resistivity. So I'll explain once again. Here see factors on which resistance of the conductor depends. So resistance depends. Normally, if you are taking small length, so resistance will be more. If you are so resistance will be less. So directly proportional. If you are taking small wire, resistance will be less. If you are taking long wire, resistance will be more. So and also if you are taking area of the cross section, best example, your water pipe. If you observe water pipe. So if you press it, okay, so more water will go. So water will be going a high with a high speed. So if you leave, more water will go. So here also, if area of the cross section is more, resistance will be less. Area of the cross section is more, resistance will be less. So area of the cross section is less, resistance will be more. So it depends on area of the cross section. Resistance depends on area of the cross section. Okay. So resistance depends on area of the cross section. That is nothing but inversely proportional. One it increases, another one decreases. So R is directly proportional to L. R is inversely proportional to area. R directly proportional to L by A. R equal to rho into L by A. So R is the resistance, rho is the resistivity. R is the resistance, rho is the resistivity. So now we are taking R equal to rho into L by A. So rho equal to RA by L. So one question is very, very important. So that is here very, very important. SI unit of resistance is ohm. SI unit of resistivity is meter square and meter get cancelled. Then you will get ohm meter. Resistivity is equal to ohm meter. Very, 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 very important. Resistivity. SI unit of resistivity is so. SI. Resistivity SI unit, everyone listen here, very, very important. Resistivity SI unit is ohm meter. Resistivity SI unit is ohm meter, very, very important. So observe here. SI unit of resistivity is ohm meter. So this derivation, they will ask for 2 marks. Resistivity is resistivity is SI unit ohm meter, because very important. That's why I'm taking, you are learning this concept. So if you are new to the channel, so you can do like, share and subscribe to Student Brand. So do like, and it will reach to the remaining students also. Okay, it will reach to the remaining students also. They will also come and join to the class, and they will learn the physics. Okay, so next we are going to the resistors are in series, resistors are in parallel. Very important. So everyone listen carefully. So I will next topic I will teach. Next topic I will teach, that is very important. Okay, so now almost 1:30, 1:30. So again you can join to the class 3 o'clock. 3 o'clock I am taking again class 3 o'clock. So join at 3 o'clock. So gap I'm giving for lunch. So for lunch I'm giving break. I'm also studying mechanical engineering. Hey Yashish, very nice. Okay. Physics is my favorite subject. Definitely, Yashish. So, surely. Okay. So, 3 o'clock again join. So, now already it is getting late. So, you have to take break. So, we have to take break for lunch. So, take break. Again join at 3 p.m. 3 p.m. So, 3 o'clock I'm taking class. And 6 p.m. and 9 p.m. So, 3 p.m., 6 p.m., 9 p.m. So, these are the live classes. So, come and join to the class. So, we'll discuss. So, until then, so bye bye. See you. Namaste. Thank you.